Good evening, Zubair.
Good evening, sir.
Yeah, good evening, everyone.
Good evening, sir. Good evening, sir.
Yeah, good evening. Here we just had some
Good evening,
festival. We had some festival over here. So just I got delayed for about 10 minutes. Okay. Let's continue now. So which topic we started in the last class? Yeah, do you remember the topic that we started in the last class? We were doing the chemical effects of electric current, right?
yes, sir.
So in the last class, we had done about the chemical effects of electric current, and we had seen that there a chemical reaction can take place by passing electric current. Okay, so that we call as the chemical effect. So, chemical effect of electric current. And we had seen here that a chemical reaction can occur by passing electric current through a solution. Okay, so if electric current is passed through a solution, then it can bring about some chemical changes or chemical reactions can occur. So that is why we call it as the chemical effect of electric current. The solution that we use is called as an electrolyte. So here we have some definition also as electrolyte. So what is the electrolyte? The salt solution of the metal the salt solution of the metal is called electrolyte. And the next is electrodes. So what are electrodes? These are metal rods. These are conducting rods dipped in the salt solution.
Good evening, sir.
Yeah, good evening. So these are conducting rods dipped in the solution, which are called as an electrodes. So you have the term electrode and the electrolyte. The complete setup or complete arrangement is called as an electrolytic cell. So the next point which we look is electrolytic cell. So what is electrolytic cell? It is the arrangement of of or you can say it is the vessel containing electrodes and electrolytes. Containing electrolyte and the electrodes.
But sir,
Yes,
like the name is electrolytic cell, no, sir. I thought that cell is a battery.
cell is a
I thought cell is a battery, sir. But I
yeah
didn't think it is a something.
yeah cell is one thing that also you have studied a cell as over there in uh, life cycle also. Okay, in bio also you have studied about cell, and here also we study an electrolytic cell. So electrolytic cell is the chamber where the electric reaction, where the reaction is occurring by passing the electric current. So for example here if I make the chamber like this. So now I create the chamber here. So this is a chamber. It contains an electrolyte. So an electrolyte is a solution of the metal. Then you have metal electrodes which are dipped in it. So we consider here two metal electrodes dipped in the solution. They can be either metal electrodes or they can be carbon electrodes. Then these electrodes are now connected to a battery. So with the help of the wire, a switch, a battery. So connections are made like this. So this one becomes the positive terminal. This becomes the negative terminal. Now let's label everything, what all we have learned here, what all things we call it. So this setup is called as so this is my electrolytic cell. This liquid is electrolyte. This is an electrode, whereas this one is also an electrode. Just okay, so just okay. So these two, they are the electrodes. These two, they are electrodes. Let's try to name all them. So this is electrolyte. This is electrolytic cell. And this is
So in this process, should the rods touch to the surface?
they may or they may not. See, there are different methods which are adopted. If you take a glass vessel, okay. So if you take a glass vessel, then the metal rods can touch.
Okay, sir.
Okay. And sometimes it happens that instead of using an anode or a cathode separately, we use a single rod. Okay. And we make the container itself to be the electrode.
So mostly if the container is a bad conductor of electricity, the rods can touch.
Yes.
Okay, sir.
Mostly it is. Generally, it is made up of glass only. If it is made up of the metal, okay, so the metal itself acts as an anode or cathode. Okay, got it. Otherwise, if you consider it to be made up of a metal, so it will obviously hinder with the reactions that are occurring in this cell. The metal will also start releasing its ion into the solution.
Okay, sir.
So, got this
Sir,
arrangement? Yes.
Sir, if the container is in metal, we
Hmm.
have to still use the rods.
If the container is metal, so we choose the proper metal and make make the container to be one of the electrodes.
Okay, sir.
So these are the understood this. What are the terminologies related to the electrolysis?
Yes, sir.
Yes, sir.
So these are the different terminologies: electrolytic cell, electrolyte, and electrodes. Now see, we had seen different processes about the chemical effects of electric current. In the last class, we had discussed about electrolysis of water. These were the few processes which we had discussed. We had discussed electrolysis of water. Then we had to discuss electroplating of copper or electroplating copper. Then we had to discuss electroplating silver.
Sir,
So both these, yes.
sir, I'm Rudra, sir. I had my science exam day before yesterday, sir. Sir, I have a doubt regarding to the chapter some natural phenomenon, sir.
Your doubts are from?
Sir, only one question doubt, sir. Sir, about earthquake, sir, the weak zones where the earthquake frequently occurs are known as.
Can you just repeat your question? Your voice was just okay. Repeat your question once more.
Sir, my question was the weak zones occur in during an earthquake are known as.
The weak forces.
Weak zones where frequently earthquake occurs, sir.
They are called.
Sir?
Just 1 minute, 1 minute. I'm able. I'm trying. Okay, just during the class, once I'm able to recall it, I'll just able tell you. Okay.
So
The
what
weak
is the electrolysis of water?
electrolysis of water is the splitting of water to give hydrogen and oxygen.
Okay, sir.
So this we did in the last class. In the electrolysis of water, what we observed, we took a chamber containing the contents as seen over here. We just took up this arrangement which was there. So the same arrangement we took. Okay, the same arrangement we took. But here, instead of taking an electrolytic solution, we had taken here water. Water was the electrolyte. Then the two electrodes, they were made up of carbon. So we called them as carbon electrodes. Here we used a 9-volt battery. So by the use of the 9-volt battery, when the current passed through water, and also we know that pure water is a poor conductor of electricity. So to make this water a good conductor, we added small amount of acid. Small amount of acid was added to this water to make it conducting. So when the water became conducting and current started to flow through this water, we observed here bubbles of gases being formed. We observed that here at the positive plate, you will have the formation of oxygen gas. So here bubbles will be formed at the positive plate and bubbles will also be formed near the negative. The bubbles formed near the negative plate, these were the bubbles of hydrogen. And the bubbles formed at the positive plate, they were the bubbles of oxygen. Okay. So where did this hydrogen and oxygen come from? So this hydrogen and oxygen, it was obtained as an electrolysis of water. We can write the reaction like this. We can write H2O having electrolysis of H2O or water. So if you perform its electrolysis, you get here hydrogen and oxygen. Now you just need to balance the equation. You multiply here by 2. Here also you multiply by 2. So you observe that you get hydrogen and oxygen by electrolysis of water. Got it?
Yes, sir.
Okay. So this was the electrolysis of water. Will everyone be able to remember the reaction and the process? So this was the electrolysis. We obtained hydrogen and oxygen. The next we do today is electroplating. So see how do we perform electroplating of substances. So this one I got here. This is electrolysis of water.
Sir, in a page you wrote the three things did in the before class, right? Where were they?
Which one?
Like in a page you wrote the three things we have done before in the before class.
Here, this one.
No, sir.
The previous class you want?
No, sir. Actually, you have written three things here, right?
Yeah, this one.
Yes. Yes, sir.
Electrolysis of water. Today we'll do electroplating of copper. Okay, electroplating
Okay.
by copper, you can say. So we want to electroplate copper on some other metal.
Sir, can you write the definition of electrolysis of water, sir? I just want to copy it down.
You want the definition of electrolysis of water?
Yes, sir.
So here, electrolysis of water. It is the splitting of water with hydrogen and oxygen. Splitting of water to give hydrogen and oxygen by passing electric current. Hmm. You got it?
Yes, sir. Thank you.
So the next one is electroplating of copper. So see how we perform the electroplating of copper. So today we'll do this electroplating by copper. Electroplating of by copper means you have to put a layer of copper on some other metal. So here what we are drawing, what we are going to do, we are going to put here a layer of copper. This is we are putting or plating a layer of copper. Plating a layer of copper on other metal. So on any other metal, we are plating, we are providing a layer of copper. How do we do it? So whatever metal is to be deposited, that metal is made here is or connected to the positive terminal of the battery, and it is called as the anode. You see, again we construct our electrolytic cell. So here we have the electrolytic cell, and we'll have an electrolyte. We'll also discuss about the electrolyte, that what electrolyte will be taken, what electrolyte should be taken over here. We'll discuss that. Then we put here two electrodes. So one of the electrode is put over here. The other one is put over here. We put the two electrodes. We need the two electrodes. Now see, I need to make one of the electrode to be the positive and the other one to be the negative. So the substance which I want to plate, like suppose here I want to coat it with copper. Here I want to put a coating of copper. So the coating of copper can be obtained. The coating of copper can be obtained by taking this electrode which to be made up of copper. So this electrode must be made up of copper. So I make this with copper. The other one which is to be electroplated, like suppose I want a steel spoon or any other substance. So that will be made with this that will be made the negative charge. So here I connect this one to the positive one, this one to the negative. Okay. So this is negative, which is cathode, and the positive is anode.
So there is no switch in between.
You can add it. Obviously, you can add it. Let me add it only. Otherwise, you will get confused. So you can add a switch anywhere. So this is the switch. I've added it. Now, the material from this copper will pass through the solution to the cathode and get deposited here on the surface of the cathode. But for this, we need one more thing here. See, the solution which is to be taken here. The solution, if I am taking this one to be made up of copper, I am taking this to be made up of copper. So the solution that I must use, the solution I must use should be a salt solution of copper. I must use a salt solution of copper. So that means it can be any salt solution of copper, like it can be CuSO4, copper sulfate, it can be copper chloride, any of them, any of the salt solution of copper can be taken over here. So copper chloride is generally not suitable over here. There are reasons why we don't use copper chloride. So we use here generally copper sulfate as the solution. Got it? So slowly what will happen? Slowly the copper, it will get deposited on, slowly the copper will get deposited over here on the surface of the cathode. Got it? Yes, students, is it clear?
Yes, sir.
Yes, sir.
So how it gets deposited, okay, that we'll see its mechanism, we'll see in the next class. How it gets deposited, like the solution here, the solution contains the ions of copper. Okay. So from the copper sulfate, the copper sulfate actually breaks to give you copper ions, Cu2 plus ions. And since the copper ions, they are positively charged, they move towards the negative electrode. So in the solution here, you have copper ions which are positively charged, and being positively charged, they start traveling towards the negative electrode. When they are attracted towards the negative electrode, and over there they reach the negative electrode, they absorb the electron from the negative electrode, become neutralized and get deposited over there.
Sir,
Yes.
like it should take lots of time to it should take lots of time to move towards the negative electron, no, sir. So should we apply more voltage, sir, in order to do this?
See, more voltage is required, not just to apply the more force. Okay. There is a different role for the voltage also. We'll see here. They do not take time. First of all, they do not take time. It is a take and give process. How it is a take and give process? It's a take and give process. The reason being, one of the copper from this copper gets into the solution, and one copper from the solution gets deposited. So it just give and take. It's not that the same ion is traveling from here to here. One of the ion gets deposited from this metal positive into the solution, and from the solution one of the ion gets deposited over here. Got it? Any other doubt?
No, sir.
Okay. Okay, bye everyone. We'll see you again in next class. I hope
Thank you, sir.
everyone has understood.
Yes, sir.
Yes.
Yes, sir.
Okay. Okay, bye everyone.
Thank you, sir.